Hey everybody. So today I have a meeting that I've got to go to, and yet you guys and your study guides are not ready for Friday. So this is going to have to suffice. What we're going to do now is finish our study guide because we have a couple more skills to go over so that you are prepared for Friday. So right now, pause the video, get out the study guides you started yesterday, or if you can't find them, a blank sheet of paper because we've got a couple skills to go over. So seriously, pause right now, and we'll start in just a moment. I'm sure you didn't just watch me stare at the camera and actually pause just now. And now everyone is absolutely ready to go. So we are going to get started. Starting with the Pythagorean theorem. This is going to be a very rough cut. I'm not going to have time to do much editing, so bear with me as this happens in real time. For some reason, I always have to share the whiteboard twice before it actually works. I don't know why. Okay, here we go. So, the Pythagorean theorem, just as a quick review of what this thing is. Draw me a right triangle real quick. Okay. So, the Pythagorean theorem has to do with right triangles. Right triangles always have a 90-degree corner in them, hence the name. And we're going to label these sides as A, B, and C. Now, C is very important, very important, because C, oh, that's not what I wanted. Undo. C is always across from the right angle. That makes it the hypotenuse. Whereas these two sides are just legs. Nothing special. So angle C is the angle. Side C is the hypotenuse. It's always the largest side, and it's always across the right angle. And the other two are just legs. So our actual formula is side length A to the second power plus side length B to the second power is going to be equal to the hypotenuse raised to the second power. So we've already practiced how to use our calculators and devices to do the power of 2. And from here on, if I say the term squared, that is the nickname. So so x to the second power has a nickname that's called x squared. Just in case you don't know what I mean by that, those are the same thing. That right there. Okay. So if you ever hear me say x squared, that means the same thing. So your job is to use this theorem to find missing side lengths. Sometimes you will have them come out to be decimals. Other times you'll want an exact value. So on my other screen here, I'm looking at the test, making sure I'm not forgetting anything. Now, granted, some of these are going to be harder than others because they have a complicated picture or something that goes along with them. But essentially, there's two kinds of problems. There's the kind where you're missing a leg, and the kinds when you're missing a hypotenuse. So we're going to do a few practice problems of each using your bonus lesson. And you feel free to pause, rewind, replay, watch it at home, share with your folks, whatever, as many times as you need to. So let's jump into a problem. Here we go. Let me zoom in a little bit. Okay. So as soon as I see this, I notice the side that's missing is the hypotenuse because it's across from the right angle. So when I set this up, I'm going to say, a squared plus b squared equals c squared. So now I'm going to fill in those numbers. That'd be 12 to the second power, or 12 squared, plus 16 squared equals x squared. Okay, so 12 to the second power. If you use your times tables or your calculator, you can find out that's 144. 16 to the second power. I think I remember what it is, but if I'm unsure, grab my device. 16 second power. Oh, that's dumb. That meant second function. Dur. Back that up. Stop that. 16 squared. 256. Yeah. Yep. Okay. So 256 still equals x squared. Yeah, just keep bringing the variable down. So 144. So, okay, so 102, that's 300. 40 and 50, so it's worth a 390. Oh, is it actually 400? $100, 200, that makes 300, 390. Yeah, it's 400. Okay. So the last step, the last thing we need to do is we're going to take the square root of both sides because I don't want x squared. What I want is x. And there's an abstract rule that just says the square root of anything that's been squared is itself. So the square root of x squared is x. Square root of 400. If you punch that into your device, unless you know it by heart, for me, so I would type in 400 and then I hit the button and it's 20. So x is equal to 20. So I look for it. 20. Bingo. Hooray. And then click on this again. Go back home. Grab any of my classes. There we go. New problems incoming. Oh, great. Perfect. So that last one was solving for the hypotenuse. This one is solving for a leg. So you all be the teacher right now. Show me, you can pause the video if you want. I'll tell you when. And see if you can figure out what I did wrong. Okay, so a squared plus b squared equals c squared. Okay, so I'm going to say 8 squared plus 9 squared equals x squared. Okay, now, right now, pause the video and see if you can figure out what I've just done wrong because I've just messed up the entire problem. You be the teacher and figure it out. Pause now. Yeah, you pause it. Okay. I'm sure we're back after a lengthy discussion between you and your 6 feet away neighbors. So what is the problem? I'll show you the problem. I'm sure someone is yelling at the screen right now because they know, and I'm proud of that person. Just be polite about it. So because the right angle is here, that means that this side, the 9, is equal to C. So I can't put the 9 in the slot for B when I substitute. So the whole equation is wrong. What I should have said is 8 squared plus B squared equals 9 squared. I guess what I could have done, instead of B, I could have put the X. Because that's what I really need to know. I need to know this side over here. Now we can go ahead and do our second powers. 8 squared is 64. We don't know what x squared is. 9 squared, 9 times 9 is 81. Now, this is where there's an extra step that you don't usually have to do in a problem where you're solving for the hypotenuse. See, I want to take the square root of x squared, but it's got stuff stuck to it right now. So I'm going to have to take away 64 from both sides. Okay, let me back up. The reason I'm taking away 64 is I want x squared to be alone. So I need to get rid of its friend over here. But because this is an equation, see the equal sign? Because it's an equation, whatever happens to one side must also happen to the other side. That keeps the universe balanced. So what I end up with is x squared equals 81 minus 81 minus 64. That'd be the same as if I added 6 to both sides, that'd be the same as 87 minus 70, so it's 17. That's just a little number talk staring back at you. Okay, so x squared equals 17. Then our last step, I take the square root of both sides. So apparently x will be equal to the square root of 17. Let's see what that looks like on Khan Academy. Okay, let's talk about different answers here for a second. So what I just said is I got this. I'm hoping it's right, so let's check. Woo! Always good to be right. Always good. Okay. But let's talk about what it would have been if they'd asked for a decimal. Hope this gum doesn't sound too bad on the mic. If it is, I totally apologize. Sound off in the comments telling Mr. Matthews not to chew gum on camera. Okay. So what if it wanted a decimal? There's what it comes out to be when I do a decimal. 4.123, 4.123, blah, 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 forever. So if the instruction were to like round to the tenths or something, just make sure you round to the correct place value. But if you have a calculator that does not give you exactsies, that's what it would be, just to prove it to you. Okay. So I've just done one where I solved the hypotenuse. I've just done one where I've solved for a leg. That's generally speaking all of the problems. So you can pause here and go back and rewatch either one to see how to solve how to solve for the hypotenuse and how to solve for a leg, and even go back and see the difference, especially on the one where you solve for leg. It's got a little extra work. But I think we're gonna go ahead and move on to our next topic. Slope. Okay. So first of all, what is slope? Well, there's a lot of ways to say this. So first of all, anytime you see the letter M, that's the letter for slope. What it's equal to is the change in y over the change in x. The rise over the run is another way to say it. Generally speaking, slope is I still think steepness is an EA, but I think it's W. You know what? We'll let the internet decide. I thought it was, yeah, I thought it right. Go me. Go English. Slope is the steepness of a line. Now, sometimes you'll have positive slope. So let's just discuss these two things real quick. So a positive slope, we're going up as you go left to right. However, it is just as common to have negative slopes. Forgive the crudeness of my drawings. Just that kind of day. All right. So the way we're going to be counting this or calculating this is looking at a graph, at a picture, or an equation for that matter, and trying to find these things. So just keep in mind and remember always that slope is denoted by the letter m. It's often shown as a fraction, the change of y and the change of x. When we count it, sometimes we call it the rise over run. There are such a thing as positive slopes and negative slopes, and you need to understand what they look like. So I guess one more sidebar before we get into some problems. Let's say we had a system like this. We had some massive line going through the system like this. Okay. Now, let's say you also, maybe I should use a grid for this. 1 second. Oh, okay, there we go. Oh, I downloaded a picture of a blank grid and then my computer said, nope, not opening that file. Okay, 1 second. There, that works. Okay, so here's some grid paper. Go us. Okay, so let's say we've got a line going through our system. Draw some dots. And here. Here, 1, 2. I'm just counting out the slope in my head. Here, 2, here, 1, 2, 3. Okay, so let's just say we've got a line that goes through all of these spots. That's pretty good. Okay, so there's our line going through all of these spots. So there's a little thing called similar triangles. Now we've been kind of doing this. That's a really hard color to read. 1 second. Okay, so we've kind of been doing this, but I've never explicitly really said it out loud. So let's just clarify what I mean. So this triangle, let's call these points A and B. Okay, that is a similar triangle to any other triangle that would connect this line. So actually, you know what? Instead of calling these points, let's just say that this is, come on. Let's call this triangle A, this triangle B, okay? So there's a few things that you will notice about them. First, okay, the reason we call them similar is because they have the exact same proportions. For instance, let's look at the rise of a run. So triangle A, 1, 2, 3. So this has, it goes down 3 and over 2. So the slope from this section is -3 over 2. That's its slope. Now, for triangle B, 1, 2, 3, 4, 5, 6. So it goes down 6, 1, 2, 3, 4. And over 4, you'll notice its slope is -6/4. So we can infer that, come on, give me the right color. Similar triangles have the same slope. Again, that color is painful to read. That's not bad. So similar triangles have the same slope. And then you can even prove these points that they have. Let's see. This point up here is -6, 8. And this one is -4, 5. Well, you can kind of predict the next one because if I go down by 6 and right by 4, which is what this triangle says, I should be at down by 6. So down 6 would be, here's the y value, so down 6, so this is going to be down to -1, and it is. And right 4 to be at 0, and it is. So yeah, you can make predictions about where these points are going to be. So just understand before we get into a problem that wink, wink, and I'm winking, if you have a diagram like this with triangles, they are called similar triangles because they have the same slope and the same proportions. There, I said it. Okay? All right, let's go ahead and get into your extra credit. Now we've already done Pythagorean, thank you. Okay, here's slope from a graph. So what I've got to do is pick 2 integer coordinates where this blue line goes through. So there's one, there's one. Any of these 2 would do. So then I'm going to notice this is a positive slope. Because it's going up and to the right, that means it's a positive slope. So what I really need to do is draw a triangle. It goes up and over. Because I did a big triangle, I might need to simplify the end, but that's all right. That's 1, 2, 3, 4, 5, 6. It goes up by 6. And 1, 2, 3. And then it goes over by 3. So the slope, which is the change in y over the change in x, the rise over the run, so went up by 6, over by 3. So if I simplified that ratio, 6 divided by 3 is 2. 3 divided by 3 is 1. So apparently the slope of this line is 2. It goes up 2 over 1, up 2 over 1, up 2 over 1. I guess that's kind of important to understand what I just said. These are the same ratio. If I go up 6 and over 3, up 6 and over 3, up 6 and over 3, that is the same as going up 2 over 1, up 2 over 1, up 2 over 1. It is the same line. So that is counting slope from a graph when it's positive. Let's see if we get a negative one. Sweet. So here's a negative one. Okay. So step 1, let's label some points. Okay, so like this one is good. And if you zoom in, I'm going to highlight something for you here. Maybe you can't zoom in, but maybe you need to squint real hard with your eyeballs. Like right here. That location is no good because this blue line doesn't go through a perfect integer coordinate. What we're looking for are the blue lines intersections with these gray crisscrosses. So like this would be fine, this would be fine, and so on. So then we'll draw a triangle. Get a color that I like. So that's down 1, 2, 3, 4, 5, 6 units. So it's dropping 6 and over 2. So moment of truth, a lot of students mess this part up. One of these is right, one of these is wrong. Which one is it? That's the question. It's this one. Because I said a while back, the change in y goes over the change in x. Okay. So that was a brief intro back into the world of slope. To be honest, that knowledge should be enough to carry you. As long as you know what you're doing. You really need to really need to practice, guys. You can back up the video. You can watch me redo these problems again and again and just finally maybe it'll click once you've done the problems on your own paper. Excuse me. You need to do your lessons. You really do. The class average on Monday and Tuesday was in the 40s, and you guys might do the same. Maybe you do better, but who knows? But doing the con lessons for bonus, that's a great plan because there's nothing about that hurts you. So I'm sorry that I'm down the hallway in a meeting somewhere, but this is the last that you'll need for your study guide to study for tomorrow's exam. So I hope it does you well. I hope you've paid attention. I hope you've left each other alone during our, distance learning opportunity of the day. All right. So add these to your notes. Remember that tomorrow during the examination, you'll get a small brief window where you'll be able to take this out, check your work. Okay. Thanks for paying attention. Please rewind and watch whatever you need to again. And now I'll see you later.